Hello, everyone, and welcome back. We are still talking about systems, and today I'm just going to kind of pull everything we've been talking about together. We're going to talk about how you solve systems of equations using any one of the three methods we've been talking about. All right. And just as a reminder about what the purpose of all of this is, right? When we're solving our systems of equations, you're looking at two linear functions on a graph, and you're looking for this place right here where the two functions, when they're graphed, they go ahead and they intersect, right? What we know about that place of intersection is that is what's called our solution. And so because your point of intersection is a point on a coordinate grid, it's always expressed as some combination of an x value and a y value in an ordered pair, x comma y. All right. So whenever you're looking to solve these systems of equations, you're looking for a place on the grid that is x comma y. You're never done solving a system unless you have both of those numbers. And like I just mentioned, there are three different ways we've talked about where you can find that ordered pair. All right. That is graphing, substitution, and elimination. So in this video, we're going to take those each step by step, one at a time, and we're going to look at what it means to solve each of those, solve using each of those methods. So if you're doing this as a part of our stations activities for this week, then you should have this worksheet in front of you called Solving Systems Three Ways. For each of the different methods we're about to use, we'll be solving the same system, just to show you that no matter which method you use, you're still ending up solving the same thing or solving for the same thing and finding the same solution every time. All right. So in this first method, we're going to take a look at graphing. It says we have to solve this system, y equals 5x minus 2. I'm going to go ahead and I'm going to color code that red for our purposes. And negative 2x plus 2y equals 12. I'm going to color code that blue. All right. We have to graph each of these equations because one of the things we can do in solving is just graph the equations and see this point of intersection. We don't have to do it algebraically. We can visually see it. So step one here says to graph each equation on the same coordinate plane. You see that to our right here. And it says you can use what you know about slope-intercept form. So this first equation that we colored red, I'll do that over here as well. You see that that one is already in its slope-intercept form. Remember, what that's supposed to look like is y equals mx plus b. So we have all the information we need to go ahead and graph this equation. If we compare the b to the y-intercepts in our function here, we see that's at negative 2, right? That's what that constant at the end means. Maybe there's a better way to color code this. I'll say b. We know that's negative 2. So let me go ahead and put that color coding over here to the, let me do that one more time. Color coding over here to the left. So because we know our b is negative 2, we can go ahead and plot that point right away. That's at negative 2 on the y-axis. And then we can go here to our m, which is in front of x. Remember, if slope-intercept form says y equals mx plus b, m is your slope, b is your y-intercept. Now, we also call the y-intercept our initial value, so that's how we knew to put that point in negative 2. And if we look over here for our slope, we know our slope is supposed to be a pattern of rise over run. That's going to tell us how we get from that initial value we plotted at negative 2 to our next point. Now, we see that if that's 5, another way to write that is as 5 over 1. Remembering you can take any whole number and turn it into a fraction by placing it over 1. So we have all the information we need to graph now. We started at negative 2 on the y-axis because that was our y-intercept. We're going to go up 5 times. 1, 2, 3, 4, 5 to the right once. And we can do that as many times as we want to. 1, 2, 3, 4, 5 to the right once. And we could also decide to do that backwards. 1, 2, 3, 4, 5 to the left once. 1, 2, 3. That's it for that. Once we have all of our points, enough points that we can feel confident in graphing a line, we're going to go ahead and do just that. We're going to graph our line. So I'm going to make a nice line that connects all of our dots here. And make it so that line cooperates. There we go. I'm going to do it on this end as well. There we go. Perfect. Maybe a little bit more over here just to make sure it hits all our dots. Perfect. All right, so that is our line for the first equation. Over here at the second one, however, we see that that one is not yet in its slope-intercept form. We have some work to do. So remember that if it's not in slope-intercept form, we can turn an equation into slope-intercept form by solving for y. So our first challenge here is going to be figuring out how to get y by itself. Now, we've done this enough times to where I don't really worry about your ability to do this, but just for safety's sake, we're going to walk through how you solve. Remember, you're going to draw your little line under the equal sign to keep the sides of your equation straight. And now we're going to think first about any terms we can get rid of. We see here, we got this negative 2x. That's not really doing anything for us. We can get rid of it by adding it to both sides. All right. That's going to leave us with 2y is equal to 2x plus 12 because of our slope, because of our commutative property, right? That tells us that we can write that whatever way we want to, 12 plus 2x or 2x plus 12. And now we're just going to finish by dividing everything by 2. So that gets divided by 2. That gets divided by 2. That's going to cancel out the 2 in front of the y. And now we're just left with y on the left side. And over here on the right side, remember, both of these terms, 2x and 12, have to get divided by this 2. 2x divided by 2, that's just going to get us 1x. Or if you want to write that as just x, that's fine too. And 12 over 2 is going to get us 6. So this is the slope-intercept form version of that equation that we were given in its standard form. All right? And so now we can go ahead and graph that just like the first one. What we know about this one is its y-intercept is at 6. And its slope, if we take a look at that m value, is 1, which we could say is 1 over 1. So what that's going to tell us we do is we go up once to the right once. And we can keep doing that for as many times as we want to. We could also decide to take that in reverse. You get the idea. And now that we've gone ahead and plotted that line, let's go ahead and graph it as well. Going to stretch it out in the right end as well. So boom, just like that. And so now we have our two lines nicely plotted. And what we notice is that there's this point of intersection right here. Let me make that a little thinner. That's better. All right. Now that point of intersection is what we spent all this time graphing to find, right? We're looking for the place where our x value and our y value is the same for both of these lines. We're looking for the place where these lines cross. And now we've done a good job of finding that. That's going to be at down here, that's 2 on the x-axis, and over here at 8 on the y-axis. So our prospective solution here is going to be at that point 2, 8. Right? Now, whenever you solve these systems, you should always be aware that there is a way to check your work. If we scroll down to step number 2, I'm going to go ahead and write that solution. You said that was 2, 8. And what step 3 tells us is we need to check our solution, right? If we're not confident that our solution actually works, one thing we can try to do is plug it in algebraically and see if it makes sense. So we can do just that. If we plug in 2 and 8 for the x and the y in both of these equations, and it makes both of the equations say something true, then we know we have the correct solution. So I'm going to go ahead and do that real quick over here. It's going to be 8 is equal to 5 times 2 minus 2. We know 8 is equal to 5 times 2 is 10 minus 2. And 10 minus 2 is going to equal 8. So that's aces there. That is 100% correct. Over here on the right, we're going to do the same thing. Negative 2 times 2 plus 2 times 8 equals 12. Let's go ahead and check that. Negative 2 times 2 is negative 4. Plus 2 times 8 is 16 equals 12. And that also simplifies nicely to say 12 equals 12. So that 100% works. And what we just did was proved that that ordered pair of x comma y, in this case 2 comma 8, makes both of our equations say something that is true. That is how we know that we have a solution. So that is method 1. We went ahead and we solved with graphing. Over here in the next method, we're going to talk about substitution. But I think I'll break that up to save it for another video. So you can catch me doing substitution in the second part of this series of 3.